At 4:40 a.m. on June 1st, Kilauea's north vent ripped open with a 650-foot lava fountain that didn't stop for 9 hours, launching ash to 24,000 feet before cutting dead without warning. That was episode 48. The moment this eruption shattered a record that had stood for 40 years. Now Hawaii is on edge, because episode 49 could ignite within hours, and no one is certain it will follow the same pattern. Just before dawn on June 1st, 2026, Kilauea's north vent erupted with a force that stunned even seasoned observers. At exactly 4:40 a.m. HST, a column of lava shot skyward, reaching heights near 650 feet. For 9 hours, the fountain maintained its intensity, pouring molten rock across the crater floor. The eruption's rhythm never faltered. Lava surged without pause, steadily resurfacing nearly 40% of Halemaumau's basin. Above, a dense ash plume built layer upon layer, eventually climbing to about 24,000 feet above sea level. The plume's shadow stretched for miles, and tephra began to settle on roads and overlooks far from the vent. Throughout the morning and into early afternoon, monitoring instruments tracked the relentless output. The scale of the event became clear as the crater floor transformed, new land forming in real time under a curtain of fire and ash. Then, at 1:37 p.m. HST, the eruption stopped in an instant. The fountain collapsed, the roar faded, and the sky cleared. 9 hours of uninterrupted volcanic fury had ended with no warning, leaving behind a crater half buried in fresh lava and a community suddenly facing questions about what could come next. The hard-stop finish brought an abrupt end to the spectacle and set off a new sense of urgency among scientists and residents alike. The current eruption at Kilauea's summit began on December 23, 2024, setting in motion a sequence that has now reached 48 separate fountaining episodes. Unlike a single explosive event, this is a monitored cycle, tracked around the clock by the USGS Hawaiian Volcano Observatory. The primary source of activity is the Kilauea vent within the Halemaumau crater, a location that sits at the heart of the summit caldera. Here, sensors and field teams collect data on ground deformation, gas emissions, and seismic tremor, building a detailed picture of the volcano's behavior. As of mid-June 2026, Kilauea remains under an advisory status. This official alert level means the eruption is ongoing, but activity is confined to the summit area and does not currently threaten communities outside the park. The corresponding aviation color code is yellow, reflecting the presence of volcanic ash in the atmosphere, but not at concentrations that would force widespread airspace closures. The yellow code acts as a caution for pilots, especially those flying near the summit or along inter-island routes. The eruption's episodic pattern is now the defining feature of this phase. With 48 fountaining events recorded, scientists are watching for changes in the interval, vigor, and style of each episode. The observatory's daily updates provide the baseline for emergency managers, public health officials, and residents who rely on clear, actionable information. This is no longer an unpredictable spectacle. It's an active process, measured and communicated through scientific monitoring, where each new episode adds to a growing record and shapes the island's ongoing response. Kilauea's current summit eruption stands apart not just for its spectacle, but for its place in the historical record. With the close of its 48th fountaining episode, the sequence has surpassed the long-standing benchmark set by the Pu'u'o'o eruption of the 1980s. That earlier event, once seen as the gold standard of episodic activity, produced 47 individual fountains over 3 years. Now, the Halemaumau Summit series has moved beyond that mark, making it the most prolific episodic fountaining eruption ever documented by the USGS. This new record is not simply a matter of numbers. For decades, volcanologists have measured Kilauea's behavior against the Pu'u'o'o template, using it to understand how magma moves, how vents evolve, and how eruption styles can shift over time. The current sequence rewrites those expectations. Each episode is meticulously logged by the Hawaiian Volcano Observatory. building a dataset that will inform research for years to come. The significance now rests in the duration and repetition of these events. Rather than a single, headline-grabbing explosion, Kilauea's summit has produced a relentless rhythm. Dozens of discrete fountains, each tracked in real time, each adding to a growing archive. This pattern allows scientists to compare intervals, measure deformation, and refine models of volcanic behavior. The eruption's legacy is being written not just in lava, but in the records and analyses that will shape the next generation of volcanic science. The Halemaumau summit sequence is now the new benchmark, setting a standard for what sustained episodic activity can look like on one of the world's most closely watched volcanoes. Gaps between eruptions at Kilauea are anything but empty time. Each pause is a clue, measured in days and in the subtle signals recorded by the Hawaiian Volcano Observatory's dense network of instruments. Historically, the interval between summit fountaining episodes has ranged from 9 to 21 days, a rhythm that scientists have come to expect until something shifts. The most recent break, an 18-day stretch between episodes 47 and 48, stands out. It's neither the shortest nor the longest, but it sits at the edge of the usual range, prompting close scrutiny of what's happening beneath the crater floor. During these pauses, attention turns to the balance of deflation and inflation. The way the ground sinks as magma drains, then swells again as new magma pushes upward. Tilt meters around the summit record changes measured in microradians, tracking the slow recharge of the volcanic system. When inflation recovers most of what was lost during the last eruption, the odds of a new episode rise sharply. Yet, not every pause means the same thing. A longer interval might suggest a slower supply of magma, or it could mean the system is storing up for a more vigorous event. The observatory's daily readings become a kind of forecast, not just for what will happen, but for how soon. In this way, the waiting period is transformed from uncertainty into data, evidence that the volcano's next move is already in motion, even before a single tremor shakes the caldera. Ash and tephra did not stay confined to the crater's rim. Fine volcanic debris drifted across Hawaii Volcanoes National Park and settled in communities downwind. Residents in Volcano Village, Mauna Loa Estates, Ohio Estates, and Mountain View woke to find a thin layer of ash on cars, roofs, and garden beds. In some park zones, up to 2 inches of tephra blanketed overlooks and trails, and the sharp, glassy strands known as Pele's hair were spotted along Highway 11 and on porch railings. This fallout changed daily routines. Outdoor activities were cancelled, windows stayed shut, and water catchment systems were covered to keep out ash. A sulfur-rich haze settled over the island's eastern corridor, making breathing more difficult and straining transport. Hawaiian Airlines cancelled flights in and out of Hilo after ash was reported on the runway, and travelers faced delays and detours across the inter-island network. County Civil Defense and HIEMA moved quickly, broadcasting alerts on local radio and mobile phones. Residents were urged to stay indoors, wear N95 masks if venturing outside, and check evacuation routes in case conditions worsened. The American Lung Association's advisory echoed across the region. Those with asthma or heart disease should avoid exposure, and everyone should monitor air quality updates. For many, the eruption's impact was measured not just in spectacle, but in the practical steps taken to protect homes, health, and neighbors. The focus now narrows to a critical window: June 13th to 15th, 2026. In these days, the possibility of Kilauea's 49th summit eruption episode hangs over Hawaii with a tension built from data, not drama. The Wekahuna tilt meters have tracked 12 microradians of inflation since the last eruption, closing in on 17.1 microradians lost during episode 48. For scientists at the Hawaiian Volcano Observatory, this recovery is more than a number. It's the threshold that has historically preceded new fountaining events. Forecast models put the highest likelihood for renewed activity inside this narrow span. Scenario planning now takes center stage. The next episode could mirror the last, with a sustained fountain and another ash plume climbing above 20,000 feet. Or, if the magma supply has built up more pressure, the eruption could exceed even the recent record, producing a longer, more powerful burst and lofting ash even higher. Each scenario brings renewed risk of ashfall, disruptions to flights, and a return of sulfur-laden air. HVO forecasters remain measured. Their approach is grounded in observation, not speculation. The volcano's signals are clear. Inflation continues, and the system shows no sign of winding down. For residents, airlines, and emergency managers, the countdown to the next eruption is not a matter of if, but when, and the clock is ticking inside a window just days wide. Right now, Kilauea's sensors register relentless pressure beneath the surface, data that signals risk isn't abstract, but imminent. As the island's future hangs on shifting ground, one fact endures: volcanic change is constant, but our preparation is not. The next eruption isn't a question, just a countdown. Stay alert.